Hello, my name is Hannah Ebo and I'm a student at DePaul University in Chicago, Illinois. Over the last term, one of the projects I've been working on is to analyze hurricane risk in the Caribbean, specifically between the two island groups of the Leeward and the Windward Islands. Some background information. First off, hurricanes are the most awesome, violent storms on Earth, according to NASA. So in regards to hurricanes, there are storms which can also be called tropical cyclones, which form off the west coast of Africa, as you can see in this image where my cursor is, and are then carried westward on the wind before hitting either the Caribbean or the east coast of North America. They can also enter the Gulf. They have a season which runs from June 1st until November 30th, with a peak in September. And then this is also a little chart where you can see the category wind speeds, damage at landfall, and storm surge. So what are the main causes of a hurricane? According to NOAA, there are three main factors which are needed for hurricane formation. The first is for an ocean surface temperature greater than 80 degrees Fahrenheit for the top 50 meters of water. Why this is important is it causes the air above it to warm, which then rises, thus creating a vacuum, which then leads to the second factor, which is a low pressure in the atmosphere. So when there's the vacuum, it actually sucks in surrounding air to fill the gap of where the warm air was that rose. Also, you need at least 50 degrees latitude away from the equator, and this is so that the Coriolis effect can take place. So the Coriolis effect is what causes the apparent deflection of anything on the Earth's surface in the northern hemisphere to deflect to the right, and the southern hemisphere to deflect to the left. However, at the equator, between 5 degrees latitude north and south, there isn't a Coriolis effect. And the Coriolis effect is what causes hurricanes to have their rotation and also their movement, the direction of their movement. Also, hurricanes generally dissipate upon landfall when they lose their heat source. So regions of the Caribbean. The Caribbean is divided into two main categories, which are the Greater Antilles in the north and the Lesser Antilles in the south. Then the Lesser Antilles are further divided into the Leeward Islands in the north of the Lesser Antilles and the Windward Islands in the south of the Lesser Antilles. So for my research, I'm focusing on these island groups, the Leeward and the Windward Islands. Why is it important to study hurricanes in the Caribbean? Well, compared to other disasters, hurricanes occur quite frequently. In specific, the year 1979 was particularly devastating. Hurricane David happened to strike just south of the island of Dominica, which actually killed 56 people and left 60,000 of the population of 80,000 displaced, which is very significant. Hurricane David then went on to wreak havoc in other islands as well. And this was just one example of a destructive hurricane. Also, other things to consider is that many of the islands in the Caribbean are volcanic and thus have steep topography. And that is a challenge for infrastructure. And also, there are many dead-end roads. For example, here in Salisbury, you can see this is a very long dead-end road. And for people who live at the end of Salisbury, if a tree were to fall during a hurricane or for any other reason the road become inaccessible, people at the end of the road, it would be very difficult to reach them with any type of aid or relief. So, my hypothesis. I hypothesize that the Leeward Islands have a higher risk associated with hurricanes, both in terms of frequency and severity, than the Windward Islands. And I hypothesize that this is likely due to the Coriolis effect. It's important to identify areas of particularly heightened risk because when it comes to disasters, increased awareness often leads to increased preparedness, which is important. So why do I think it's because of the Coriolis effect? This is an image taken of the surface temperature during the month of September, which is seasonally normal. And you can see above South America, there's this little patch of hot water. So if the Coriolis effect didn't exist, I would hypothesize that the hurricanes, which, because of what I talked about earlier, which pick up steam and intensify over this hot water, they would just move due west and plow into the Windward Antilles, or the Windward Islands. However, because of the Coriolis effect, I hypothesize that the storms which pick up severity over this patch are then going to deflect right, move slightly northward, and hit the Leeward Antilles. So for my methodology, the first thing I did was gather data from NOAA. When I got the data from NOAA, it included hurricane categories as well as tropical depressions and storms. So the first thing I had to do was clean up my data. And to do that, I excluded anything that was below a category Hurricane 1. Then I classified the other categories, the other hurricanes, into the respective category 1 through 5. And this is an image that depicts my cleaned up data. Once I did that, I narrowed the focus to the Lesser Antilles. So I created a buffer for both the Leeward and the Windward Island groups, and I chose a 50-mile buffer because that is within 50 miles of a hurricane eye is where you're going to experience the strongest gale force winds. So I just wanted to focus on those most intense winds for the islands that were impacted. So I also did them separately because I didn't want to have any overlap between the islands of Dominica and Martinique, where you can see that they're both within 50 miles of the Leeward and the Windward buffers. So then I clipped the Atlantic hurricanes to each buffer separately and found the average wind speed and number of hurricanes per square mile for both regions, which I will discuss more in my results. Next, I applied the linear directional mean, which is essentially just the average hurricane path for each category. So where was the most hurricane category 4s on average, kind of like that. And so the linear directional mean is a spatial statistical tool in ArcMap. And to do this, what I needed to do is actually create a new buffer, which is not depicted in this picture, but that I clipped all of the hurricanes to this buffer, which included both Leeward and Windward Islands, so that I wouldn't double count this little region of overlap. Then I ran the statistic. So you can see that hurricane categories 1 through 4, because there is no 5, they all fell within the Leeward Island group, which significantly supports my hypothesis. Then I analyzed hurricanes which I intersected the actual land, so not the buffer, but actual land masses. So first I totaled the square miles of land for both the Leeward and the Windward groups. Interestingly, the Windward has a little bit over double the amount of land than the Leeward. However, the Leeward Island had 44 hurricanes and the Windward Island only had 13 hurricanes, which is quite a big difference. Also, I analyzed hurricanes which their eye intersected the buffer. And for the Leeward Islands, you can see there were 218, and the Windward Islands, there was only 79, even though the square miles of buffer is relatively similar. So this is, again, a significant difference and supports my hypothesis. Then I created a box plot, which looked at the wind speeds and the severity. So for the Leeward Islands, the severity had an average wind speed of 90.6, while the Windward was only 85.7. I also looked at the outliers. So the highest wind speed for the Leeward Islands was 138, while the highest wind speed for Windward Islands was only about 130. Then the reason that they're both having the same base is because anything less than 74 miles per hour is a tropical storm or depression. So that's why they have an identical base. Now the results for this box plot and for the severity are not quite as significant as they were for frequency. However, it still does point to my hypothesis, just not as strongly. So in conclusion, based on frequency and the linear directional mean, it is appropriate to accept the hypotheses that the Leeward Islands have a higher risk associated with hurricanes, both in terms of frequency and severity, than the Windward Islands. However, it cannot be confirmed that this is due to the Coriolis effect at this time. Future research. I would like to run a matched pair test to see how statistically significant my results are. Also, I would like to do more research to try and identify if the Coriolis effect is in fact a cause of the heightened risk. Otherwise, what could other possibilities be? Could it be because of the ocean depth? What are other factors? And then I also noticed when I applied the same method to all Atlantic hurricanes that there is a very strong southwestern movement as the storm intensity increases. So you can see category 1, 2, 3, 4, and 5. And it makes sense logically that it would decrease as you get further north, again, because we talked about the basic factors which cause and fuel hurricanes. As you move further north, you move further from the equator, and then the water temperature is cooler, so it's natural and it's expected that they wouldn't be as intense. However, I can think of several reasons which could potentially cause the severity to increase moving westward. So could it be, again, because there's shallower water in this region? Could it be because they had longer time to form before reaching there? Could it be that they formed more recently? So I'm interested in finding out why this is happening. And then on the last slide, I have my references. And that concludes my presentation. So thank you so much for watching. I hope you enjoyed it, and I hope you have a great day. Bye.